So in this session, I'm happy to feature the platform projects in PERC and introduce the speakers from each of the PERC platforms. So we're starting with the social science platform and Dr. Peter Phillips. Dr. Phillips is a distinguished professor of policy and the founding director of the Center for the Study of Science and Innovation Policy at the Johnson Shoyama Graduate School of Public Policy at the University of Saskatchewan. He earned his PhD at the London School of Economics, and over the past 25 years, he's held research chairs and professional appointments in agricultural economics, business, political studies, and now public policy. His research explores bioscience innovation policy related to global food security. And his presentation today will address responding to the climate crisis with biotechnology. Dr. Phillips, please.
To some extent, you are my biome. You're all interested in studying the biome at varying orders. I'm interested in how you operate, interact, and what you do and how it has an influence on the economy. So I've changed it slightly. I'm not just going to talk about biotech. I'm going to talk about the biosciences and make it relevant to the data-rich world that we're trying to contribute to. I want to accomplish three things. I want to step this back one step and talk about the challenges to agriculture and food security, particularly around the climatic conditions we're in. I want to talk about agriculture as part of the problem and part of the solution set, and then talk about the pathways. And the pathways are mostly through innovation, how we can move to a data-rich, sustainable agricultural system. So the climate challenges are not what most people think. We're not short of food. We've got enough food in the world to feed everybody. We've got enough food in the world to make everybody fat. That's a fact. The problem is that it's not in the right places, in the right structures, and in the right availability. So it's still a basic challenge for us, and it is particularly bad in areas where we have malnourishment and weak or non-existent production spaces. But we have a major disconnect in that world. 11% of our world's currently hungry, and it's growing, and our population is growing. So we need more volume, and we need more volume that can get to the right people at the right time. The challenge is that forget 2050. Let's look at 2020. In 2020, our biocapacity is under stress. You can see most of the place where food is produced is red. We're already eating into our bio capacity to produce food. We're not quite as bad as many other countries, but the United States, China, India, most of the Maghreb, and much of Europe, which is major sources of food for the world population, is not sustaining its productive capacity. And climate just simply makes that a lot worse. Some parts might get better, but they're going to be different. But most of the parts are getting worse, particularly the parts where we're short of food. And that's the conundrum we faced. And the interesting thing is that we're one of the top 5 countries in the world that produces food for people in the world, And the way we keep people from starving is we move food around. And some of the major food exporting parts of the world are no longer going to be major growth areas. So we're exacerbating the food problem. And of course, it's not an equal problem. Some of the crops, corn, rice, soy, the world's going to be harder to produce the volumes in the regions that we currently produce. Wheat, because of where it's produced, generally will not be the high risk crop space. So we have to spread it around a bit there. Similarly, some regions are more at risk. We don't have a problem. Even if we didn't produce any food, we'd have enough food to feed ourselves. We can afford to buy it. But one region in the world, which is already the most food insecure part, sub-Saharan Africa, will actually dip below carrying capacity for its population by 20 I can't remember, I've lost the scale. I think it's 2050. So that's the only jurisdiction that will actually be worse off. So I said I want to talk about agriculture as part of the problem and part of the solution set. Agriculture currently represents about 15 to 25% of the greenhouse gas emissions based on national numbers, and about 18% globally. The emissions are all over the place, but they tend to be steady, dropping somewhat, steady in aggregate, but the volume is steady, but our share of the world is going down as we're creating more emissions elsewhere. And the greenhouse gas is largely from animals, that's rising. And when it is from plants, it's from things that we have some interest in, but not complete interest. Fertilizer, rice, crop residues, burning, and drains organic soils. And nitrogen is the political hot button for the next while anyway. So how are we doing? The parts of the world that we're particularly focused on as scientists and industrial actors is doing pretty well. North America, Europe, the Oceania, that the amount of greenhouse gases being emitted is very small. The problems are in Africa, South America, and Asia, where the emissions are large and disturbingly in at least 2 of the 3 regions, growing. We can do more without doing anything new. We just have to figure out how to get what we can do now in the hands of people who are not able to access it today. So if we know from studies that adoption, once something is introduced into the market, the actual peak uptake and use and value to society is about 23 years out. That's a long ways out. And a lot of times the diffusion is truncated, it's stop and go. Whole parts of the world are cut out of some of the changes that we're able to produce in North America and Europe. Overall, the pressures are a mix of economic, regulatory, and social barriers. But there's a lot of missed opportunities. If you take corn, for instance, take the US as the baseline, you can see that Argentina could double its production if it could figure out how to use the latest agronomic traits available. India could get more than 5 times the volume from the same acreage just by using the latest package of seeds plus technology. And the barriers are significant. When it works really well. Lana did some work of looking at how Western Canada's dryland crop production activity, Alberta, Saskatchewan, Manitoba, contributes to greenhouse gases. And this is the Saskatchewan numbers, but what you can see is that back in 1985, when min-till, zero-till was just sort of a dream and a promise from people, where we had 5% of our land mass using it, we were significant emitters of greenhouse gases in Saskatchewan. But you can see as adoption, you can't see the adoption rate, but as adoption picked up, by 2007 we were net zero. And since 2007 we've been a carbon sink in terms of Scope 1, Scope 2 emissions in agriculture, primary crop agriculture in Saskatchewan. Alberta similarly, they came a bit later, Manitoba's not quite there yet. We did none of this because of environmental policy. We did it because it was good soil management, it was good for profitability. So when the policies start to align and push us towards greenhouse gas emitting policies, we may get new incentives, new structures, and move a lot further than we have here. So that takes me to the future. Where are we going from here? The FAO has said to get to the 2050 world of people being fed and having sustainable and adequate nutrition around the world, we need to manage a whole bunch of things. They're a mixed bag of things. There's no surprises there. But pretty much every one of those requires some innovation. Maybe not technological innovation, but social innovation, cultural innovation, political innovation, regulatory and industrial innovation. The problem is that in absence of that, what you do as scientists and what the industries do as commercial entrepreneurs is really high risk. You may have heard this notion of the valley of death. In this case, a couple of colleagues, Graf and others in the United States, looked gathered a data set of about 560 different inventions that got to the technology readiness level 3, which means they've got the proof of concept. They're not just crazy ideas at this point. Of that 560, two were in the market for more than a year. But it wasn't the regulators that were the guilty party here. 98% of that cull, that death march through the valley of death, was because the scientists, the industry, and others said, not good enough, not worth the effort, not interesting enough. So we're dealing with a really tiny portion of what you do gets to application and use globally. But there's a corresponding policy response in terms of getting to interesting stuff. We do all kinds of mission-driven research. That's what we are. That's what that PIRC is. We do a lot of public-private partnerships. We do a lot of effort to clean up that regulatory system and not discourage people from getting towards it. And ultimately, there's a significant effort to try and improve diffusion of the technologies, try and broaden the market somewhat from where it is now, so that we don't just get 0.4 of 1% of everything that gets to TRL3 into use. Imagine if you can just double or triple that. You don't need any more investment. You just need fewer barriers, fewer hurdles. So how does that relate to where we are? We're in a digital play. We're trying to create a digitally rich agriculture. First problem is the match of opportunities and risks. We did a series of studies. Stuart Smythe led the team, and a bunch of us. You saw Diego McCall give a talk earlier this afternoon on the slides, on the videos. We did a series of surveys over an extended period of time, and one question we asked is, which data matters? What data will actually drive things? And we were asking people who were in industry and government and bench scientists. And you can see sort of the ordinal ranking. Genomics is important, farmer data is important, phenomics are important, logistics, geospatial, consumption. That little graph over there shows the problem. The stuff that's important is also problematic. The more important it is, the more people say, hey, I'm not so sure I like the way you're using my data. So there's some issues there that are at least on the horizon. We have opportunities, but the opportunities aren't secure. Related to that, and this is where I think the opportunity comes for groups like ours, is that one of the solutions is trusting the people that are governing the space you're attached to. In terms of data management, data manipulation, data conservation, our surveys were showing, and this is not unique to our work, many have found this, that people generally have confidence in universities and statistical bureaus. Not absolute confidence. It's 2/3 of the world says, all other things being equal, I trust them not to rip me off with my data or damage my data in ways that's problematic. But most of the data that you need to make the job work, the data we talked about in the previous slide, the logistics, the farmer, the consumption data, is industrial data. It comes from somebody other than universities. And so by definition, we're going to be forced into a relationship with people that are not generally trusted by the expert community, let alone the consumer population. Third point I want to leave you with is that we asked people about all kinds of different hurdles, problems that they foresee in terms of taking the data that is generated in programs like ours or right across this supply chain of data-rich opportunities, and ask them what do they think is going to be the reason for not sharing or not being willing to share, and what are the sort of the barriers to exploiting this data that we're creating, because the value is in multiple uses, not a single use. And if you look down that list, there's no regulation there. This isn't governments telling you not to do it. These are really practical problems in projects, in institutions, between institutions. It's building the norms and structures for how we might effectively manage the flow of data. And in absence of doing this, the costs go up. The costs of finding data, the costs of negotiating exchanges, the cost of enforcing those exchanges, the rules of those exchanges. So part of what we in conjunction with Jeremy DeBeer, who you've heard a couple of times over the last 7 years in this project, we spent some time trying to think about what are the governance processes that are out there. For those of you who are at sort of the front end of this exercise, you're probably aware of the FAIR principles, that we're trying to, there's a whole set of sub-principles, but you're trying to create findable, accessible, interoperable, and reusable data. That's a mouthful. It's very practical. It's very down to earth. It's making sure there's metadata there, making sure that it's in programs that if they're not the same program, that they talk to each other and the data can be used efficiently and effectively. That's what you do at the micro-institutional lab level. The reality is that Venn diagram of circles over there. The world is very complicated. You're not alone. The world is out trying to figure out top down how to set the norms, the rules, the exchange conditions, the principles that will drive the free flow of data between areas. There's a societal group that sort of circles around the UN and has public and private actors. There's a group that comes at this strictly from an intellectual property perspective. There's a group that comes at it from a very economic business perspective that tends to anchor around the WTO, World Trade Organization, and its rules. And then there's an environmental group, which is a bit off to the side at the time we were doing this, but is increasingly encroaching and helping to define what this world will look like. But it's an evolving space. So whatever you do at the FAIR level, at the institutional level, will be a challenge that will be either fit in and create the preconditions and the underpinnings for this international set of rules, or it will be tripped up by those rules. So let me leave you with a couple of conclusions. The ag and food space and security in them they're being challenged by a whole bunch of things, but probably the big pressing one on the public agenda is climate. And agriculture is both winning and losing on that agenda. It's perceived as a core part of the problem, and in many ways it is. 23% of the global emissions come from agriculture. But it's also a potential solution set, because many of those can be addressed relatively easily, and in Saskatchewan's case, we demonstrated without any policy driving us towards that, we're able to move quite a ways along the path to change. The technologies and resources do exist to move us along a pathway to impact, but there are hurdles. And the hurdles are not trivial. I don't want to trivialize these. The norm in the intellectual commercialization space is the research activity you do is the easy part. That the hard part is getting that and figuring out how to make it commercially viable or socially desirable and impactful in use. That's the hard part. That's that valley of death that you have to go through with your ideas. And there are vital and valuable opportunities here, but they need to be governed better. And you'll be part of that solution set. As you build norms in your parts of this space, you will be creating some of the preconditions for us to be able to put together a system that will work for the breeders and work for the consumers in the world. Thank you.